This is number 25, angles of triangles. How are the angle measures of triangles related? We're going to classify triangles by sides and angles, and then find interior and exterior angle measures of triangles. So, a triangle is a polygon with 3 sides. You can classify triangles either by their sides or by their angles. So if we're going to classify triangles by their sides, then there are 3 types: scalene, isosceles, and equilateral. A scalene triangle has no congruent sides. An isosceles triangle has at least 2 congruent sides, and an equilateral triangle has 3 congruent sides. If you're going to classify triangles by their angles, then there are 4 types. There is an acute triangle, a right triangle, an obtuse triangle, and an equiangular triangle. An acute triangle has 3 acute angles. A right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. And an equiangular triangle has 3 congruent angles. Remember that an acute triangle is an angle, or an acute angle is an angle that measures less than 90 degrees. A right angle measures exactly 90 degrees, and an obtuse angle measures greater than 90 degrees, but less than 180 degrees. So here are some examples. The first one says, classify the triangles by their angles. And then the second one says, classify triangle XYZ. So go ahead and pause right now. Try to figure out the answer, and then come back when you have it. So I hope you actually took some time to pause, and let's take a look. Now remember, in this particular case, we are classifying triangles by their angles. So in this first triangle, all the angles are 60 degrees. And if we're classifying them by angles, then this is equiangular. In the second triangle, we have 3 angles: a 30-degree angle, a 130-degree angle, and a 20-degree angle. There is at least 1 angle that is obtuse. So this is an obtuse triangle. In example number 2, it says classify triangle XYZ. So triangle XYZ is actually going to be X, Y, Z. So the whole thing. And so, let's see here. Just scoot up a little bit. So when we look at this, we know this angle is 50, this angle is 40, but this angle right here is 50 plus 40, which makes it actually 90 degrees. So this would be a right triangle. All right, next. Classify the triangular shape of the support beams in the diagram by its size, sides, and by measuring its angles. So it could potentially be kind of hard to see. So I'm going to highlight it for you. Here is the triangle, and that kind of didn't make it any better. Let me see. Maybe if I pick yellow. Nope, that didn't work either. Maybe if I thicken up my line. Let's try that. And let's do a red. Oh, perfect. So here's my triangle. And then it had these 2 lines on it. Okay, and it says that I need to classify by side and by angle. So those 2 lines tell me that I have 2 congruent sides. So that means it's going to be isosceles when I talk about the sides. And then if, well, we don't know yet, but looking at this, then we know that all of our angles are going to be acute. And we'll talk about some other things a little bit later, where we can talk more specifically about the angles based on the sides. All right. So example number 4, classify triangle OPQ by its sides, then determine whether it's a right triangle. And then I gave you a little hint. I said use the distance. That should say distance formula. Let me fix that. Use the distance formula to find the lengths, then check the right angles using slope. So I want you to go ahead and pause here right now. try to classify triangle OPQ by its sides and then come back. Make sure you try it on your own before you come back. Okay, so we're going to look at each of the sides. So the first side that I'm going to look at here is PQ. So I need the length of PQ, and that's going to be the square root of -1 minus 6 squared plus 2 minus 3 squared. So that's -7 squared, which is 49, plus -1 squared, which is 1. So that's going to be the square root of 50. Okay, and 50 is 5 times 10. So 5 times 5 times 2. So that's going to be 5 root 2. So how did I get that? 50 is 5 times 10, and 10 is 5 times 2. So I have a pair of 5s and then a 2. So the pairs go on the outside. What's left goes on the inside. Then I'm going to do QO. And so that's going to be the square root of 6 minus 0 squared plus 3 minus 0 squared. So that's 6 squared, which is 36, plus 3 squared, which is 9. So the square root of 36 plus 9. So that's going to be the square root of 45. Okay. And then 45 is going to be 9 times 5. And 9 is 3 times 3. So I have 3 times 3 times 5. So that's going to be 3 root 5 for QO. And then lastly, we have PO. And PO is going to be the square root of -1 minus 0 squared plus 2 minus 0 squared. So -1 squared is 1. 2 squared is 4. So that's going to be the PO is going to be the square root of 5. So we have our lengths. None of them are equal. None of them are the same. So if we're going to classify by sides, then we're going to say that it is scalene because there are no equal sides. And now we need to determine if it's a right triangle. So if it's a right triangle, then that means that we need to find the slope of each of these lines so that we can determine if any of them are perpendicular. Okay, so the slope of PQ is going to be 2 minus 3 over -1 minus 6. So that's -1 over -7, which is 1/7. The slope of QO is going to be 3 minus 0 over 6 minus 0, which is 3 over 6, which is 1/2. And then the slope of PO would be would be 2 minus 0 over -1 minus 0. So that's going to be 2 over -1, which is -2. And so then if you take a look, you see that the slope of QO is 1/2 and the slope of PO is -2. So those are opposite reciprocals, so that we can say that QO is perpendicular to PO. And so here's QO here, and here's PO here. So then we know right here would be a right angle. So classify triangle OPQ by its sides, then determine whether it's a right triangle. So this is a scalene right triangle. Scalene right triangle. So finding angle measures of triangles. When the sides of a polygon are extended, other angles are formed. The original angles are the interior angles. The angles that form linear pairs with the interior angles are exterior angles. So whatever is inside of my polygon those angles are my interior angles. And whatever is outside of my polygon, those angles are my exterior angles. So here are my exterior angles because they are outside of triangle ABC. Okay, so that's going to be critical as we move forward. So card number 42 is the triangle sum theorem. It simply says that the sum of the measures of the interior angles of a triangle are 180. So the measure of angle A, which is this angle, plus the measure of angle B, plus the measure of angle C is 180 degrees. So something I think you pretty much know, but remember, before we can make statements, we have to have a theorem behind it. And then once we have proven the theorem, then that theorem is useful or usable.